Numbers don't have to exist purely in your head. By treating math as a physical blueprint, we can draw equations right onto the page. Our goal today is to map three distinct operations, addition, subtraction, and multiplication, onto one continuous physical path. To build this, you need a piece of paper, a pencil, and most importantly, a ruler. The logic of this map entirely depends on plotting intervals with perfectly equal spacing. If the gaps vary, the math breaks. Every map needs a starting point. Because we are charting the set of whole numbers, which explicitly include 0, unlike standard counting numbers, our starting reference point, or origin, must be 0. This diagram shows the construction of our tool. Let's draw a straight horizontal line. Using your ruler, mark evenly spaced intervals from 0 up to 12. You now have a complete, perfectly spaced number line. This single structure will let us translate indivisible calculations into visible physical direction and measurable distance. Let's test this map with our first operation, the addition problem 5 plus 3. In this system, addition dictates one physical rule: you move to the right. As values accumulate, your pencil travels rightward along the line. We begin with the first number in our equation. Place your pencil firmly on the 5. The second number dictates our travel. Execute 3 individual, equally sized jumps right. We land cleanly on 8. 5 plus 3 equals 8. The math checks out. Addition is a literal physical accumulation of distance, stepping sequentially in a positive direction from a designated starting point. Step 2. Let's tackle the second operational challenge with a subtraction problem, 9 minus 4. If addition moves right to show an increase, subtraction requires the spatial inverse. To represent a decrease, your physical movement goes strictly to the left. Find your starting position from the primary number. Anchor your pencil right on the 9. The second number is 4, requiring us to track backward. Map 4 sequential jumps to the left. We hit 5, proving 9 minus 4 equals 5. Visually mapped, subtraction is the exact inverse of addition, a deliberate physical reversal of distance previously gained. Now we introduce the final complex operation on our page, the multiplication problem 2 times 6. To map this correctly, we must apply a completely different approach. Do not put your pencil on the 2. Unlike addition or subtraction, the rule of multiplication is that movement always begins at the absolute origin, 0. On this map, multiplication acts as repeated addition. The first number dictates how many jumps to take, and the second number dictates the size of each jump. We need 2 jumps of 6 spaces each. Launching directly from 0, execute your first massive leap, spanning 6 full spaces to land on the 6. From there, execute a second identical leap, spanning another 6 spaces to land precisely on 12. Multiplication functions by scaling distance. Compounding these equal jumps from 0 reaches the final product through repeated steps of the same size. Review your paper. You have successfully built a visual guide for basic whole number operations. This split-screen chart compares the distinct patterns you've proved on the page. Short rightward jumps from a starting number give us addition. Short leftward jumps yield subtraction, and equal jumps launching from 0 give us multiplication. Now test your new foundational tool. Grab your pencil and independently map out 2 new problems, 3 times 3 and 10 minus 6. By mastering all of these physical rules, you replace abstract numerical confusion with predictable, controllable geometry on the page.